Maybe I should have started with tan inverse because it actually falls out a bit quicker and a bit simpler than the other ones, okay? So we'll start off in exactly the same way. Okay? But we have to note the restriction, which is minus pi on 2 to pi on 2. This time we are not inclusive. Okay, because we're very discriminatory like that. Alright, now what's the derivative? The derivative with respect to y, okay, is sec squared y. Okay? Now you turn this over, right, in order to get dy and dx. And you might think, ah, that's a reciprocal. I'll write it as cos squared, okay, which would work, okay. But remember what our goal is, right? I want to get this back in terms of x. I want to get back to tan, right? So cos squared is actually going a step away from tan. Sec squared is actually a better option. So I'm going to leave that as 1 on sec squared. Now what is the identity that's going to be useful to us here? Yeah. Good. So that's 1 plus tan squared there, okay? And I don't need to fuss around with any plus or minus here, which is nice, because I don't have a square root involved, yeah? So I can just go straight here. Okay, done. That's it. I can go home, alright? So in fact, this is the simplest of the lot. No. Alright, now, yeah, question. Say that again. Now, why did I bring the restriction? Shh. I'll wait. Because I shouldn't really have to raise my voice to someone who's 4 meters away from me, right? Thanks. You know, you guys know me. I don't mind talking, but if it's that kind of talking which stops actual communication, that's probably inappropriate. The question was about the restriction, right? So this time here, why did I note the restriction? I only noted it because, well, this only equals this. I can only go from here to here if I include it, right? Because if I don't, then I've got the whole lot, which is not actually tan inverse, okay? But do I need to bring the restriction back into play? And the answer is no, because there was no square root involved, so I didn't need to decide between plus or minus, okay? Which is why I had to bring it in before. So that's why the range restriction doesn't reappear, because it's not important to the algorithm. Okay. Right, now, before I tell you about what's on your desk, okay, the forms that you actually will see most frequently are not the derivatives of sine inverse, cos inverse, or tan inverse, but ones involving chain rule, okay? So I'm going to show you what they are. We're going to work what the derivatives are together. Okay, if a is a constant, okay, so this is chain rule here, right? How good are we at doing this? We know you've just written down what the derivative of just regular sine inverse is, okay? So how would it work if I were doing chain rule here? Well, chain rule, you do the inside, then you do the outside. So what's the derivative of the inside? If a is just a constant? 1 on a, good. Okay, now what's the derivative of the inside? So I just did the inside. The outside, it's 1 on the square root of. Now, watch out, because this is chain rule, right? If we'd gone the full way and done the substitution, at this point here we would write like u squared, right? Where u is equal to blah, okay? So this is not going to be x squared here, it's going to be x on a all squared, okay? Now I'm just going to skip that line and go straight there, because I wonder if you can see why that will be useful to me, right? See how I have this a out the front, okay? I can simplify things by bringing it inside underneath the square root sign, but once it goes underneath it becomes a squared, right? So this is 1 on the square root of a squared minus x squared, because a squared there and the a squared there cancels, okay? Now you also see this form, y equals 1 over a tan inverse of x on a. Now you might wonder, why do they stick another 1 on a out the front, okay? Well, let's see what happens, okay? When you do the derivative, okay, I've got 1 on a as a constant out the front, so I'll just write that down. And now I initiate chain rule, right? So I do the inside, which is 1 on a. Okay, now I do the outside. Now what's the derivative of tan inverse? It's that, right? Except instead of 1 plus x squared, I'll have, just like here, x squared on a squared. Right? Okay, now you can see why they often will slap this extra 1 on A out the front. Because now I have an A squared here, which again will do the same sort of cancelling thing. Okay? So that's 1 on A squared plus X squared.